go ahead and try the trig integral on the screen. Before I go through my solution, I wanted to point out that there are 19 days left in this maths countdown series. We are rapidly approaching the end of the series. We have just under 3 weeks left, so make sure you stick around until the end. Okay, so if we look at this integral, it's convenient that we have tan and secant, because we know the derivative of tan is indeed secant, and the derivative of secant is indeed tan x secant x. So it's very useful then that we have our integral in terms of these two trig ratios. So what we can do now is try and manipulate this inner expression such that we have the derivative of one of those functions, either tan or secant, being left over, so that when we make a substitution, we are substituting in for that as well. So I'll show you what I mean. So we're going to say that this integral is equal to the integral of tan to the 5th power of x times by secant squared of x times by secant squared of x. And we've left this one secant squared of x out because it's the derivative of tangent of x. And now by splitting it, we have this extra secant squared of x, which we can express in terms of tan. So we have the integral of tan to the 5th power of x. And then sec squared of x is the same as saying tan squared of x plus 1 times by secant squared of x dx, just completing the integral. Okay, so what we can do now is we can let u equal to tangent of x. So what that allows us to do then is when we differentiate in terms of u, when we differentiate u in terms of x, we get secant squared of x dx. Okay, so continuing with the integral, now expressing it in terms of u, we get u to the power of 5, because tangent is now being substituted for u. So we get u to the power of 5 into u squared plus 1. And then for secant squared dx, we're substituting in du. Okay, so if we expand this inner expression, we get the integral of u to the power of 7 plus u to the power of 5 du. And integrating this, we get u to the power of 8. We increase the exponent by 1 and we divide by the new exponent, plus u to the power of 6 over 6 plus c. Now all that's left for us to do is to express this integral in terms of x. So if we initially substituted u for tangent of x, now we can substitute tangent of x back for u. So we have tangent to the 8th power of x over 8 plus tangent to the 6th power over 6 plus c. And that's the integral solved. So I hope you found this video useful and insightful and interesting. And if you did, please don't forget to leave it a like and subscribe to my channel. Thank you for watching.